Hello friends, Uh, I hope you guys are enjoying winters and hi, this is again, and today what I'm going to teach you in this video that how you would be able to create a very simple convolutional neural network, a deep learning model in Matlab. You know, Matlab is a very interactive platform and there are many built-in functions available already in Matlab. So it's really good, easy platform to start understanding the deep learning concept. Here I'm going to explain you how you can create your own small deep learning model and train with a data set. Right now I'm going to show you a built-in data set available in Matlab. Okay, you can use your own any custom type of data set, the whatever you want. So this is a imds dataset. This dataset is the very basic version. I have already uploaded so many videos in Python to train your model, convolutional neural network on upon this dataset. You can use some other type of dataset if you have. Okay, the easiest way to train your model with your own dataset. I'm going to show you some some a sample dataset like. Let's say this is a one of the sample data set, though this it belongs to one of the PhD students, so I cannot explain about much about the data set, but all you need to do, just place all your images in a folder and name that folder by the image name. I can show you some other type of data set as well in the beginning session so that you can understand. Previously, I have created a video for celebrity face recognition. So let me open that data set, celeb. Yeah, this is the celebrity data set. Here you can see in each folder containing some sample of images, like here 50 cent, and I named this folder as a 50 cent. So once the Matlab has a built-in capability of image data store, which can read all the which can store the name of the images present in the folder, and okay, and label that images, because in the classic convolutional neural network, what I'm going to show you a classification problem, how you would be able to classify multiple um, number of images, like in this case of celebrity dataset, you have n number of images and each folder containing many samples, and the folder name is named as by the celebrity name. So image data store, what exactly it do, like let me show you. This is the data store which contain the labels, like here you can see a total number of images present in the dataset is 10,000, and each label, the number of labels are 10, 0 to 9, okay, and each label containing 1000 samples for each. So first 1000 samples as label as 0, second is 1, third is 2, and things like that, and the last samples label as 9. So you can load all the images directly into your workspace by the help of image data store. All you need to do, give the path of the folder, okay, and include subfolder means all the image available inside any folder will be stored in your database. Okay, label source means what are the label source you are considering. Right now I'm considering the label source by the folder name. So once I call this image data store and pass these parameter, my imds containing the number of images present in the folder and each label and the all the images present inside the folder label as the name as the folder. Okay, so let me show you the sample images. These are the sample images like 4 4 5 3 5 8. Okay, imds dataset is provided by a university for the purpose of classification uh, task, and this is very quite famous. While you will be at the beginning stage of convolutional understanding the deep learning concept, you can start with this data set. The entire source code I will be made available through the link provided in the comment section, and the source code I have already pasted. I also also insert in the description section of the video. You can access the source code. Okay, guys. So let's move forward. I have explained you what is the role of data store. You can randomly see some images present in your database. The image count label is preferably used for the total number of label present in the dataset. Here you can see each label 0 containing 1000 samples up to all label 9. Each labels containing 1000 number of samples. Moving forward, you require to know what is the size of input image in MATLAB. One of the problem of built-in functionality that you need to not in MATLAB but in entire deep learning model, you need to resize all the input samples in fixed dimensions. Right now we have grayscale images and each image size is 28 by 28. Once you have the size of images, you can design your deep neural network. Deep neural network is nothing else but containing an input layer. Input layer is basically designed uh, for taking the input size to feed into the first convolutional layer. Okay, here the input layer containing the length of images, breadth of images, and the number of channel available in the images. Okay, we have an input image of grayscale. That's why channel is stand for 1. If you have RGB images, you can go. You need to put here 3 instead of 1. Thereafter, moving forward, you the first layer, convolutional 2D layer. Okay, for the convolutional filter, the parameter, it's really simple in convolutional neural network. First you will give the filter size. Thereafter, number of filter. Padding same means the input and input size of image and output size of image remain the same. 3 means it basically traverse the image with the help of matrix size 3 by 3. Output number of filter will be 8. Okay, as these images are small in size and having very low complexity and less number of features to be analyzed, that's why I'm using less number of filter. If we have more number of features to be analyzed and the sparsity of data will be high, then I definitely we need to move toward the higher number of filter in first convolutional layer. Moving forward, thereafter you will add a batch normalization layer. What batch normalization layer will do, it's a really important to understand the concept of batch normalization. Okay, it normalizes the activation function. Just right after, you can see here the value activation. It normalizes this activation function through the method of gradient propagation. So in a layman words, what it do, it actually take input mini batch and normalize all the mini batch in same dimension, so that it can speed up the network training time while introducing the non-linearity into the network. Okay, thereafter we will move toward the ReLU layer. ReLU layer is definitely none of the problem in the universe is can be separable with the just like a none of the problem in the universe is linearly separable. So while all the above functions is more dependable on upon the linear separation and feature inspection, ReLU introduce non-linearity in the curve so that the output will be more distinguished. Total number of label will be more distinguished and can be separable even if they contain the non-linearity in its features. Moving toward, it's really important the final year. I'm actually designing this a few lines, 1 2 3, only single convolutional neural network, finally end up with the max pooling. The purpose of max pooling, after activation, uh, the max pooling sometimes followed by the, we need to increase, we can downsample the number of features and increase the filter if we add second convolution layer, what it will do, from an input image, okay, it push take all the take a matrix and the most dominant features push to the next layer. Okay, in that way it actually downsample the number of features while not increasing the computational complexity of the network. So it's really important to understand the max pooling. Like it has a strike 2, that means input image size, let's say 28 by 20, then output of the max pooling will be downsample by twice. So output will be the 14 by 14 matrix. Thereafter, we'll move toward the fully connected layer, because we have the linear matrix of 10 labels. So we need to we need to convert all the input features into one dimensional, so that it would be it can multiply with the final fully connected layer. So it basically, the purpose of the fully connected layer, it's combine all the features coming from it's actually recompile all the features as coming from the output of the max pooling. And the softmax, it is a layer we use for the classification purpose, and classification layer is finally uh, distinguish the label of the input sample. Once we have this layer model ready, let me show you. You have layer like this containing 8 layers. First is input image, second is convolutional 2D layer, third is batch normalization, fourth for ReLU layer for non-activation, max pooling for downsampling the image, fully connected layer for make n dimensional into one dimensional, feature size, softmax layer is used prior to classification layer, and finally classification layer is map the input feature into the label, a number of classes available in the dataset. Then you need to define some training parameter. We are using here stochastic gradient descent momentum SGGM with the initial learning at 0.01, maximum number of epoch 20, one epoch is 10 for all the training data, complete one round of training. Okay, shuffle in every epoch means none of at the beginning of second epoch you don't need, every training data will shuffle each other, so that it won't get overfitted toward the training data. IMD validation data containing 250 images as training containing 750 samples out of 1250 IM validation, and plot true, verbose true, it show the training process, plots true, that during the training process you can see how the model is converging. Once you initialize, you define the options of in here in how you will going to train your model. There is a simple built-in method available in Matlab. You just call this method train network containing image train. Thereafter the layer, the network you define, and the option, what training options you are providing inside the network, and the training will start. Sorry, I need to define image validation, so I'm going to call this entire program again.
मैं चला हाँ मैं बोल
So now here the training process will get initialized, and you can see how the model is converging. I'm going to train this model for 20 epochs, because my network is the number of layer are 2 is very less, so that it can converge and will show the maximum possible accuracy on upon corresponding to validation data. Here in this training process you will see, while the training is initialized, the validation is also followed by the same. That means model is not overfitting on upon the training set, and can be extend toward the validation data. Once entire training process will complete, you will be able to see how much validation accuracy at the end you have achieved, and thereafter we will move toward how the classification, how this train model can be applied for the classification. You have validation accuracy 98.12% in 20 number of epoch, while the validation loss is also really low. Okay, initial learning rate is 0.1. I'm training this model on single GPU. Okay, and this accuracy being achieved on 20th on upon 20 epoch. Now let's move toward the classification and see how the accuracy look like. So there is a very basic inbuilt method available. Once you train the network, all you need to call a built-in method available in Matlab. Classify. You pass the trained network inside it and the image validation data, because I'm using a split function for training and validation data. If you have some other data for the testing purpose, you can call that data and pass into the classify method, and you will get the all predictions label. Once you have the prediction label, you can fetch the image validations label available and compare them to get the overall accuracy. Okay, this is a very simple. The number of samples in y prediction with equal to the number of samples in y validation data, which is the original number of labels, divided by the total number of samples available, stand for the accuracy. Okay, this is 0.98, and if you multiply this line with the 100, you will get accuracy in percentage. 98.12% accuracy. So guys, I tried to explain you how these you can design your own convolutional model. All you need to do understand how you can design the layer. Okay, there are plenty of tutorial also available. If you like this tutorial, just make a thumbs up and subscribe my channel. It helps me to boost for creating more and more video for my users. So yeah, important thing I am going to explain you again. All you need to do, understand that your all input data should be same size, and you need to pass that size into input layer. Thanks for watching this video, guys, and keep subscribe me, and love you.